The Tunguska Event was a large explosion, which occurred near the Podkamennaya Tunguska River in what is now Krasnoyarsk Krai, Russia, at about 07:14 KRAT on June 30, OS June 17, 1908. The explosion occurred at an altitude of 5 (10 km) at 60.886 degree N, 101.894 degree E. Different studies have yielded widely varying estimates of the impacting object size, on the order of 60 am to 190 am. It is the largest impact event on or near Earth in recorded history. It is classified as an impact even though the asteroid or comet is believed to have burst in the air rather than hitting the surface. Since the 1908 explosion, there have been an estimated 1,000 scholarly papers published on the Tunguska explosion. Many scientists have participated in Tunguska studies. The best known are Leonid Kulik, Yevgeny Krynov, Kirill Florensky, Nikolai Vladimirovich Vasilyev, and Wilhelm Fast. In 2013, a team of researchers led by Viktor Kvasnitsaya of the National Academy of Sciences of Ukraine published analysis results of microsamples from a peat bog near the blast epicenter showing fragments that may be of meteoric origin. Estimates of the energy of the blast range from as low as 3 to as high as 30 megatons of TNT. Most likely it was between 10 and 15 megatons of TNT, and, if so, then the energy of the explosion was about 1,000 times greater than that of the atomic bomb dropped on Hiroshima, Japan. Roughly equal to that of the United States Castle Bravo ground-based thermonuclear test detonation on March 1, 1954. And about 2/5 that of the Soviet Union's later Tsar bomber. It is estimated that the Tunguska explosion knocked down some 80 million trees over an area of 2,150 square kilometers, and that the shock wave from the blast would have measured 5.0 on the Richter scale. An explosion of this magnitude would be capable of destroying a large metropolitan area, but due to the remoteness of the location no fatalities were documented. This event has helped to spark discussion of asteroid impact avoidance. Description: At around 7:17 am local time, Evans natives and Russian settlers in the hills northwest of Lake Baikal observed a column of bluish light, nearly as bright as the sun, moving across the sky. About 10 minutes later, there was a flash and a sound similar to artillery fire. Eyewitnesses closer to the explosion reported that the source of the sound moved from the east to the north of them. The sounds were accompanied by a shock wave that knocked people off their feet and broke windows hundreds of kilometers away. The majority of witnesses reported only the sounds and the tremors, and did not report seeing the explosion. Eyewitness accounts of the sequence and duration of the events vary. The explosion registered at seismic stations across Eurasia. It is estimated that, in some places, the resulting shock wave was equivalent to an earthquake measuring 5.0 on the Richter scale. It also produced fluctuations in atmospheric pressure strong enough to be detected in Great Britain. Over the next few days, night skies in Asia and Europe were aglow. It has been theorized that this was due to light passing through high-altitude ice particles that had formed at extremely low temperatures, a phenomenon that many years later would be produced by space shuttles re-entering Earth's atmosphere. In the United States, the Smithsonian Astrophysical Observatory and the Mount Wilson Observatory observed a months-long decrease in atmospheric transparency due to an increase in suspended dust particles. Selected eyewitness reports. Testimony of Semenov, as recorded by Leonid Kulik's expedition in 1930. At breakfast time I was sitting by the house at Venevra Trading Post, 65 kilometers per 40 miles south of the explosion, facing north. I suddenly saw that directly to the north, over Uncle's Tunguska Road, the sky split in two and fire appeared high and wide over the forest, as Semenov showed, about 50 degrees up. Expedition note. The split in the sky grew larger, and the entire northern side was covered with fire. At that moment I became so hot that I couldn't bear it, as if my shirt was on fire. From the northern side, where the fire was, came strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut closed, and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that such noise came, as if rocks were falling or cannons were firing, the earth shook, and when I was on the ground, I pressed my head down, fearing rocks would smash it. When the sky opened up, hot wind raced between the houses, like from cannons, which left traces in the ground like pathways, and it damaged some crops. Later we saw that many windows were shattered, and in the barn a part of the iron lock snapped. Testimony of Shutran of Shanyagar tribe, as recorded by I.M. Suslov in 1926. We had a hut by the river with my brother Chikaran. We were sleeping. Suddenly we both woke up at the same time. Somebody shoved us. We heard whistling and felt strong wind. Chikaran said, "Can you hear all those birds flying overhead?" We were both in the hut, couldn't see what was going on outside. Suddenly, I got shoved again, this time so hard I fell into the fire. I got scared. Chikaran got scared too. We started crying out for father, mother, brother, but no one answered. There was noise beyond the hut, we could hear trees falling down. Chikaran and I got out of our sleeping bags and wanted to run out, but then the thunder struck. This was the first thunder. The earth began to move and rock, wind hit our hut and knocked it over. My body was pushed down by sticks, but my head was in the clear. Then I saw a wonder, trees were falling, the branches were on fire, it became mighty bright. How can I say this, as if there was a second sun, my eyes were hurting, I even closed them. It was like what the Russians call lightning. And immediately there was a loud thunderclap. This was the second thunder. The morning was sunny, there were no clouds, our sun was shining brightly as usual, and suddenly there came a second one. Chikaran and I had some difficulty getting out from under the remains of our hut. Then we saw that above, but in a different place, there was another flash, and loud thunder came. This was the third thunder strike. Wind came again, knocked us off our feet, struck against the fallen trees. We looked at the fallen trees, watched the treetops get snapped off, watched the fires. Suddenly Chikaran yelled, "Look up," and pointed with his hand. I looked there and saw another flash, and it made another thunder. But the noise was less than before. This was the fourth strike, like normal thunder. Now I remember well there was also one more thunder strike, but it was small, and somewhere far away, where the sun goes to sleep. Sibir newspaper, July 2, 1908. On the 17th of June, around 9 a.m. in the morning, we observed an unusual natural occurrence. In the North Karolinsky village, 200 versts north of Kurensk, the peasants saw to the northwest, rather high above the horizon, some strangely bright bluish-white heavenly body, which for 10 minutes moved downwards. The body appeared as a pipe, that is, a cylinder. The sky was cloudless, only a small dark cloud was observed in the general direction of the bright body. It was hot and dry. As the body neared the ground, the bright body seemed to smudge, and then turned into a giant billow of black smoke, and a loud knocking was heard, as if large stones were falling, or artillery was fired. All buildings shook. At the same time the cloud began emitting flames of uncertain shapes. All villagers were stricken with panic and took to the streets. Women cried, thinking it was the end of the world. The author of these lines was meantime in the forest about 6 verst, 6.4 kilometers north of Kurensk, and heard to the northeast some kind of artillery barrage, that repeated in intervals of 15 minutes at least 10 times. In Kurensk in a few buildings in the walls facing northeast window glass shook. Siberian Life newspaper, July 27, 1908. When the meteorite fell, strong tremors in the ground were observed, and near the Lovat village of the Korn squares 2 strong explosions were heard, as if from large-caliber artillery. Krasnoyarsk newspaper, July 13, 1908. Kizmsko village. On the 17th an unusual atmospheric event was observed. At 7:43 the noise akin to a strong wind was heard. Immediately afterwards a horrific thump sounded, followed by an earthquake that literally shook the buildings, as if they were hit by a large log or a heavy rock. The first thump was followed by a second, and then a third. then the interval between the first and the third thumps were accompanied by an unusual underground rattle, similar to a railway upon which dozens of trains are traveling at the same time. Afterwards for 5 to 6 minutes an exact likeness of artillery fire was heard, 50 to 60 salvos in short, equal intervals, which got progressively weaker. After 1.5 2 minutes after one of the barrages 6 more thumps were heard, like cannon firing, but individual, loud and accompanied by tremors. The sky, at the first sight, appeared to be clear. There was no wind and no clouds. However, upon closer inspection to the north, that is where most of the thumps were heard, a kind of an ashen cloud was seen near the horizon, which kept getting smaller and more transparent and possibly by around 2:03 p.m. completely disappeared. Investigations. There was little scientific curiosity about the impact at the time, possibly due to the isolation of the Tunguska region. If there were any early expeditions to the site, the records were likely to have been lost during the subsequent chaotic years World War I, the Russian Revolution of 1917 and the Russian Civil War. The first recorded expedition arrived at the scene more than a decade after the event. In 1921, the Russian mineralogist Leonid Kulik, visiting the Podkamennaya Tunguska River basin as part of a survey for the Soviet Academy of Sciences, deduced from local accounts that the explosion had been caused by a giant meteorite impact. He persuaded the Soviet government to fund an expedition to the Tunguska region, based on the prospect of meteoric iron that could be salvaged to aid Soviet industry. Kulik's party eventually undertook an expedition in 1927. Upon arrival, Kulik made arrangements with the local Evenki hunters to guide his party to the impact site. Reaching the explosion site was an extremely arduous task. Upon reaching an area just south of the site, the superstitious Evenki hunters would go no farther, fearing what they called the Valleyman. Kulik had to return to the nearby village, and his party was delayed for several days while they sought new guides. The spectacle that confronted Kulik as he stood on a ridge overlooking the devastated area was overwhelming. To the explorer's surprise, no crater was to be found. There was instead around ground zero a vast zone of trees scorched and devoid of branches, but standing upright. Those farther away had been partly scorched and knocked down in a direction away from the center. Much later, in the 1960s, it was established that the zone of leveled forest occupied an area of some 2,150 square kilometers, its shape resembling a gigantic spread-eagled butterfly with a wingspan of 70 kilometers and a body length of 55 kilometers. Upon closer examination, Kulik located holes which he erroneously concluded were meteorite holes. However, he did not have the means at the time to excavate the holes. During the next 10 years there were 3 more expeditions to the area. Kulik found several dozens of little pothole bogs, each some 10 to 50 meters in diameter, that he thought might be meteoric craters. After a laborious exercise in draining one of these bogs, he found there was an old stump on the bottom, ruling out the possibility that it was a meteoric crater. In 1938, Kulik arranged for an aerial photographic survey of the area covering the central part of the leveled forest. The negatives of these aerial photographs were burned in 1975 by order of Yevgeny Krasnoyarsk, then chairman of the Committee on Meteorites of the USSR Academy of Sciences. It was done under the pretext that they were a fire hazard, but the truth may have been the active dislike by official meteorite specialists of anything associated with an unyielding enigma. However, positive imprints would be preserved for further studies in the Russian city of Tomsk. Expeditions sent to the area in the 1950s and 1960s found microscopic silicate and magnetite spheres and siftings of the soil. Similar spheres were predicted to exist in the felled trees, although they could not be detected by contemporary means. Later expeditions did identify such spheres in the resin of the trees. Chemical analysis showed that the spheres contained high proportions of nickel relative to iron, which is also found in meteorites, leading to the conclusion they were of extraterrestrial origin. The concentration of the spheres in different regions of the soil was also found to be consistent with the expected distribution of debris from a meteorite airburst. Later studies of the spheres found unusual ratios of numerous other metals relative to the surrounding environment, which was taken as further evidence of their extraterrestrial origin. Chemical analysis of peat bogs from the area also revealed numerous anomalies considered consistent with an impact event. The isotopic signatures of stable carbon, hydrogen, and nitrogen isotopes at the layer of the bogs corresponding to 1908 were found to be inconsistent with the isotopic ratios measured in the adjacent layers, and this abnormality was not found in bogs located outside the area. The region of the bogs showing these anomalous signatures also contains an unusually high proportion of iridium, similar to the iridium layer found in the Cretaceous-Euro-Paleogen boundary. These unusual proportions are believed to result from debris from the falling body that deposited in the bogs. The nitrogen is believed to have been deposited as acid rain, a suspected fallout from the explosion. Earth Impactor Model, Asteroid Airburst. The leading scientific explanation for the explosion is the airburst of an asteroid 6–10 kilometers above Earth's surface. Meteoroids enter Earth's atmosphere from outer space every day, traveling at a speed of at least 11 kilometers per second. The heat generated by compression of air in front of the body as it travels through the atmosphere is immense, and most asteroids burn up or explode before they reach the ground. Since the second half of the 20th century, close monitoring of Earth's atmosphere has led to the discovery that such asteroid airbursts occur rather frequently. A stony asteroid of about 10 meters in diameter can produce an explosion of around 20 kilotons, similar to that of the Fat Man bomb dropped on Nagasaki, and data released by the U.S. Air Force's Defense Support Program indicate that such explosions occur high in the upper atmosphere more than once a year. Tunguska-like megaton range events are much rarer. Eugene Shoemaker estimated that such events occur about once every 300 years. Blast patterns. The explosion's effect on the trees near the epicenter of the explosion was replicated during atmospheric nuclear tests in the 1950s and 1960s, and was similar to the effects of the conventional Operation Blowdown. These effects are caused by the blast wave produced by large explosions. The trees directly below the explosion are stripped as the blast wave moves vertically downward, while trees farther away are knocked over because the blast wave is traveling closer to horizontal when it reaches them. Soviet experiments performed in the mid-1960s, with model forests and small explosive charges slid downward on wires, produced butterfly-shaped blast patterns strikingly similar to the pattern found at the Tunguska site. The experiments suggested that the object had approached at an angle of roughly 30 degrees from the ground and 115 degrees from north and had exploded in mid-air. Asteroid or comet. In 1930, the British astronomer F.J.W. Whipple suggested that the Tunguska body was a small comet. A cometary meteorite, being composed primarily of ice and dust, could have been completely vaporized by the impact with Earth's atmosphere, leaving no obvious traces. The Comet Hypothesis was further supported by the glowing skies observed across Europe for several evenings after the impact, possibly explained by dust and ice that had been dispersed from the comet's tail across the upper atmosphere. The cometary hypothesis gained a general acceptance amongst Soviet Tunguska investigators by the 1960s. In 1978, Slovak astronomer One-half-Yur Bok-Rizike suggested that the body was a fragment of the short-period comet Encke, which is responsible for the Beta Tauride meteor shower. The Tunguska event coincided with a peak in that shower, and the approximate trajectory of the Tunguska impactor is consistent with what would be expected from such a fragment. It is now known that bodies of this kind explode at frequent intervals tens to hundreds of kilometers above the ground. Military satellites have been observing these explosions for decades. In 1983, astronomers Zdeněk Šikanin published a paper criticizing the comet hypothesis. He pointed out that a body composed of cometary material, traveling through the atmosphere along such a shallow trajectory, ought to have disintegrated, whereas the Tunguska body apparently remained intact into the lower atmosphere. Šikanin argued that the evidence pointed to a dense, rocky object, probably of asteroidal origin. This hypothesis was further boosted in 2001, when Farinella, Foschini, al. released a study suggesting that the object had arrived from the direction of the asteroid belt. Proponents of the Comet Hypothesis have suggested that the object was an extinct comet with a stony mantle that allowed it to penetrate the atmosphere. The chief difficulty in the asteroid hypothesis is that a stony object should have produced a large crater where it struck the ground, but no such crater has been found. It has been hypothesized that the passage of the asteroid through the atmosphere caused pressures and temperatures to build up to a point where the asteroid abruptly disintegrated in a huge explosion. The destruction would have to have been so complete that no remnants of substantial size survived, and the material scattered into the upper atmosphere during the explosion would have caused the ski glows. Models published in 1993 suggested that the stony body would have been about 60 meters across, with physical properties somewhere between an ordinary chondrite and a carbonaceous chondrite. Christopher Chibber and others have proposed a process whereby a stony meteorite could have exhibited the behavior of the Tunguska impactor. Their models show that when the forces opposing a body's descent become greater than the cohesive force holding it together, it blows apart, releasing nearly all its energy at once. The result is no crater, with damage distributed over a fairly wide radius, and all of the damage being blast and thermal. Three-dimensional numerical modeling of the Tunguska impact done by Yuzhnikov and Rudenko in 2008 supports the Comet hypothesis. According to their results, the comet matter dispersed in the atmosphere, while the destruction of the forest was caused by the shock wave. During the 1990s, Italian researchers, coordinated by the physicist Professor Giuseppe Longo from University of Bologna, extracted resin from the core of the trees in the area of impact to examine trapped particles that were present during the 1908 event. They found high levels of material commonly found in rocky asteroids and rarely found in comets. Kelly et al. Contend that the impact was caused by a comet because of the sightings of noctilucent clouds following the impact, a phenomenon caused by massive amounts of water vapor in the upper atmosphere. They compared the noctilucent cloud phenomenon to the exhaust plume from NASA's Endeavour space shuttle. In 2010, an expedition of Vladimir Alexeyev, with scientists from the Troitsk Innovation and Nuclear Research Institute, used ground-penetrating radar to examine the Suslov crater at the Tunguska site. What they found was that the crater was created by the violent impact of a celestial body. The layers of the crater consisted of modern permafrost on top, older damaged layers underneath, and finally, deep below, fragments of the celestial body were discovered. Preliminary analysis showed that it was a huge piece of ice that shattered on impact, which seemed to support the theory that a comet caused the cataclysm. In contrast, in 2013, analysis of fragments from the Tunguska site by a joint US-European team was consistent with an iron meteoroid. Lake Checo. In June 2007, scientists from the University of Bologna led by Professor Giuseppe Longo identified a lake in the Tunguska region as a possible impact crater from the event. They do not dispute that the Tunguska body exploded in midair but believe that a 1-meter fragment survived the explosion and struck the ground. Lake Checo is a small, bowl-shaped lake approximately 8 kilometers north-northwest of the epicenter. The hypothesis has been disputed by other impact crater specialists. A 1961 investigation had dismissed a modern origin of Lake Checo, saying that the presence of meters-thick silt deposits at the lake's bed suggests an age of at least 5,000 years, but more recent research suggests that only a meter or so of the sediment layer on the lake bed is normal lacustrine sedimentation, a depth indicating a much younger lake of about 100 years. Acoustic echo soundings of the lake floor provide support for the hypothesis that the lake was formed by the Tunguska event. The soundings revealed a conical shape for the lake bed, which is consistent with an impact crater. Magnetic readings indicate a possible meter-sized chunk of rock below the lake's deepest point that may be a fragment of the colliding body. Finally, the lake's long axis points to the epicenter of the Tunguska explosion, about 7.0 kilometers away. Work is still being done at Lake Checo to determine its origins. The conclusions of the Italian scientist were published on the website of the University of Bologna. The main points are that Checo, a small lake located in Siberia close to the epicenter of the 1908 Tunguska explosion, might fill a crater left by the impact of a fragment of a cosmic body. Sediment cores from the lake's bottom were studied to support or reject this hypothesis. A 175 cm long core, collected near the center of the lake, consists of an upper sea. 1 meter thick sequence of lacustrine deposits overlaying coarser chaotic material. 210 Pb and 137 Cs indicate that the transition from lower to upper sequence occurred close to the time of the Tunguska event. Pollen analysis reveals that remains of aquatic plants are abundant in the top post-1908 sequence but are absent in the lower pre-1908 portion of the core. These results, including organic C, An and I13C data, suggest that Lake Checo formed at the time of the Tunguska event. Speculative conjectures. The behavior of meteoroids in Earth's atmosphere was less well understood during the early decades of the 20th century. Due to this, as well as the paucity of relevant data resulting from Soviet secrecy during the Cold War, a great many other conjectures about the Tunguska event have sprung up, none of which are accepted by the majority of the scientific community. Fragment of 2005 NB56. One study suggests that a chunk of 2005 NB56 caused the 5 Euro 10 megaton fireball, bouncing off the atmosphere and back into orbit around the Sun. The scientists involved in the study claim that the object that caused the event will pass close to Earth again in 2045. However, the orbit of 2005 NB56 has been computed on the basis on an observed arc of only 17 days, and it is therefore impossible to predict its position in 1908 with sufficient accuracy to verify the possible connection. Natural H-bomb. In 1989, Serge J. D'Alessio and Archie A. Harms suggested that some of the deuterium in a comet entering Earth's atmosphere may have undergone a nuclear fusion reaction, leaving a distinctive signature in the form of carbon-14. They concluded that any release of nuclear energy would have been almost negligible. Independently, in 1990, KRAT copyright Tunguska Event proposed that a deuterium comet, that is, a comet with an anomalous high concentration of deuterium in its composition, could have exploded as a natural hydrogen bomb, generating most of the energy released. The sequence would be the first time a mechanical or kinetic explosion triggered a thermonuclear reaction. These proposals are inconsistent with our knowledge of the composition of comets and of the temperature and pressure conditions necessary for initiating a nuclear fusion reaction. Studies have found the concentration of radioactive isotopes in the blast region to be inconsistent with those expected following a nuclear explosion, fusion or otherwise. Edward Trebuchevsky has suggested that the event was caused by the explosion of the hydrogen-saturated part of the nucleus of a comet that struck Earth's atmosphere, with most of the remaining comet nucleus surviving, and possibly continuing to orbit the Sun. Black hole. In 1973, Albert A. Jackson and Michael P. Ryan, physicist at the University of Texas at Austin, proposed that the Tunguska event was caused by a small black hole passing through Earth. This hypothesis is considered flawed, as there was no so-called exit event a second explosion occurring as the black hole, having tunneled through Earth, shot out the other side on its way back into space. Based on the direction of impact, the exit event would have occurred in the North Atlantic, closer than the impact event to the seismic recording stations that collected much of the evidence of the event. The hypothesis also fails to account for evidence that cosmic material was deposited by the extraterrestrial body, including dust trails in the atmosphere and the distribution of high nickel magnetic spherules around the impact area. Antimatter. In 1941, Lincoln La Paz, and later in 1965, Clyde Cowan, Chandra R. Atlery, and Willard F. Libby suggested that the Tunguska event was caused by the inhalation of a chunk of antimatter falling from space. As with the other hypotheses described in this section, this does not account for the mineral debris left in the area of the explosion. Geophysical hypothesis. Astrophysicist Wolfgang Kunter suggested the Tunguska event was caused by the sudden release and subsequent explosion of 10 million tons of natural gas from within Earth's crust. The similar event-shot hypothesis has also been suggested as a possible cause of the Tunguska event. Similar events. The Tunguska event is the strongest, but not the only, example of unexplained explosion events or bolide air bursts. There have been a number of similar events. Modern developments in infrasound detection by the Comprehensive Nuclear Test Ban Treaty Organization and infrared DSP satellite technology have reduced the likelihood of undetected airbursts. A much smaller airburst occurred over a populated area in Russia on February 15, 2013, at 7:25 Moscow time at Chelyabinsk in the Ural district of Russia. It inflicted over 1,200 injuries, mainly from broken glass falling from windows shattered by the meteor's shock wave. In popular culture, see also, Potomsky crater, about 830 km to the east-southeast, Sikhote-Alin meteorite, 1947 impact, references, notes. Bibliography. External links, article about the events, special attention to Leonid Kulik on mysterydatabase.com, Tunguska.ru Russian site with a tiny English section. Includes some gorgeous Tunguska photos. Tunguska, a research group at University of Bologna that has conducted several recent expeditions to the site. Tunguska pictures, many Tunguska-related pictures with comments in English. Quasi-three-dimensional modeling of Tunguska comet impact drive. Andrei Zlobin, paper of 2007 Planetary Defense Conference. Discovery of probably Tunguska meteorites at the bottom of Kushmo River's shoal. Dr. Andrei Zlobin, paper 1304.8070 in arXiv.org, Tunguska similar impacts and origin of life. Dr. Andrei Zlobin, paper 1402.1408 in arXiv.org, Tunguska similar impacts and origin of life. Dr. Andrei Zlobin, article in electronic journal Modern Scientific Researches and Innovations. December 2013. A12. Tunguska cosmic body of 1908, is it from planet Mars? John Anfinogenov, Larisa Budava, Dmitry Kstzev, Yana Anfinogenova, paper 1401.6391 in arXiv.org, have Tunguska meteorites been found? I have my doubts. Bad Astronomy, Slate Magazine, Dr. Phil Platt, May 6, 2013. The Tunguska Event in 1908, Evidence from Tree Ring Anatomia Evnei A. Vaganov, Malcolm K. Hughes, Pavel P. Silkin and Valery D. Nesvtalo, Astrobiology, Volume 4, No. 3, 2004, ppA 391 399, Preliminary results from the 1961 combined Tunguska meteorite expedition, probable asteroidal origin of the Tunguska cosmic body. A 2001 paper arguing for the asteroidal hypothesis. Russian alien spaceship claims raise eyebrows, skepticism article, arguing the event was caused by meteor explosion. The Verdlock conjecture website explores the science behind the black hole impact hypothesis. 1908 Siberia explosion. Reconstruction by William K. Hartman. Simulation of such an event and origin of King Tut's glass, team makes Tunguska crater claim, astronomy picture of the day on Tunguska, mystery space blast solved, sound of the Tunguska event, the Tunguska event 100 years later. NASA, there was a hot time in Tunguska that night, a discussion of the Tunguska events as a test site for theory in triple canopy. Huge Tunguska explosion remains mysterious 100 years.